Dear students, we very well know in the studies and research of social sciences and particularly of population studies, investigating and making scientific inquiry on various social, economic, demographic and cultural issues is an important thing. In this regard, using of information technology plays an important role to simplify the process of various research methodologies, collection of data, its storage and analysis processes. In this module, we are going to look at various computing systems and also softwares that have been used in the research methodologies, especially regarding to population studies. In the past few decades, there has been a revolution in computing and communication, and all indications are that technological progress and use of information technology will continue at a rapid pace. Accompanying and supporting the dramatic increase in the power and use of new information technologies has been the declining cost of communication as a result of both technological improvements and increased competition. These advances present many significant opportunities but also pose major challenges. Today, innovations in the information technology are having wide-ranging effects across numerous domains of society, and policymakers are acting on issues involving economic productivity, intellectual property, rights, privacy protection, and affordability and access to the information. Choices are hence made now will have long-lasting consequences, and attention must be paid to their social and economic impacts. Students, we will look at the use of computer applications in population studies. The computing power during the past 3 decades has been increasing with phenomenal step, which is in turn has resulted in the development of new methods of statistical analysis. Computers increased storage capacity and processing power, which enables students to experience and explore every aspect of the statistical process. However, computer-based technology has also brought with it many new challenges for researchers who seek to determine what it has to offer and how that should be delivered. Several statistics packages are available like Stata, eViews, SPSS, Minitab, etc., which verify considerably in their power and scope. There are several processes generating large-scale data sets which need to be analyzed to get insights of these processes. Researchers need modern mathematical and statistical computer applications of data analysis. Computer applications allow researchers to do many things in modern ways that enhance the quality of the data. In some cases, it also allows researchers to do the things that were not possible before. Computer applications are using systematic way of doing things. Correct interpretation of results obtained by these applications needs basic knowledge of statistical methods and know-how of strengths and weaknesses of software being used for the analysis. Commercial computer applications like Statistica, Minitab, Mathematica, MATLAB, R, and Excel are used by researchers usually. Researchers have shown that the reliability of statistical software cannot be taken for granted because level of understanding of software and known how makes a lot of difference in the results. Now we'll discuss about accessing, retrieving and managing the data. While years ago, students and researchers had to use a library of similar institution to gain access to bibliographic data files, which now such services are available from one's desktop using the web or external storage units such as CD-ROM or DVD-ROM. Large bibliographic databases are available in these forms as a vast amount of data in form of statistical tables and maps. One major development in interactive access to data by means of the web are various methods that have been used for interactive access to both performated text files and pre-coded data files. The software technology for archiving and analyzing social data is less than a half century old, but it is very plausible to expect that many advancements in next 50 years. Interactive data analysis sites of the web hint about what these advances might be. The refinement of such systems faces issues such as how to balance functionality with ease of use and plausibility of standardizing interfaces for many numeric data files and the use of gateways between the web and third-party software such as statistical packages. It will take considerable research and development to sort out the feasibility of providing many different analytical facilities in the web environment. A major challenge is determining the amount and type of data documentation necessary for typical users to get meaningful results in a reasonable amount of time. A considerable challenge is created when a variety of types of materials are necessary for retrieving useful data related information. The main types are text, graphics, metadatabases, which are about databases, fielded text or data, such as bibliographic databases, and multimedia, which are audio or video clips. Now we will discuss about qualitative computing. Computer-based content analysis began with Stone in 1966 and Associates and now plays an important role in the social sciences. A survey of 110 qualitative-oriented researchers found 3/4 regularly used computers. Ragan and Becker has persuasively claimed that qualitative research using these computing tools yields more systematic attention to diversity, for example, by encouraging a more thorough examination of comparative contrast among all the cases. This type of computing became much more common as researchers combined content analysis with other tasks associated with quantitative as well as qualitative analysis. Several general purpose programs for qualitative analysis have been widely distributed, as cited by Sess, Fielding and Lee. These tools make the analysis of a large amounts of text more accurate and effective and potentially direct the focus of attention, authentic and analytical procedures. The general tasks of text entry, code assignment, counting and data organization have been extended to include special routines for improving the quality of coding and code management. Hesser-Bieber, Dupuis, Kinder and Carley have stated that technically extended this methodology to include the management and analysis of audio and video segments as well as the text. Now we will discuss about simulating and modeling. Early in the history of sociological computing, Coleman and McPhee and Glasser designed computer simulation models and showed how they could be used to identify elusive implications of different theoretical assumptions. Other social scientists followed in their footsteps, but the excitement of the pioneers was lost and few simulations and formal computer models were developed in 1970s. With the emergence of artificial intelligence and other modeling methodologies, social researchers demonstrated renewed interest in formal computer-supported models of social processes. New computer simulations for social policy analysis as well as pedagogy or instruction have emerged as well across all over period. Neural networks combined with the techniques of artificial intelligence and expert systems have excited a number of social scientists to work in this area. Neural nets organize computer memory in ways that model human brain cells and their ability to process many things is in parallel. Systems that use neural nets are especially good when patterns matching is required. However, the computations require high performance computers. The practice of computing in social research has evolved rapidly. Computers have been applied to practically conduct every research task, including such unlikely ones as interviewing, and hundreds of other tasks. This variety of computer applications will continue to evolve with the newer internet-based technologies. The application of computing to sociology is not without problems. Errors in data and software abound, yet rarely do social scientists check their results by running more than one program on the same data. Data and software tend to be very costly, but there are many impediments to the sharing of these critical resources. Better software is needed, but graduate students often are discouraged from programming new softwares, and they continue to work on the old softwares without updating to the technology. Nonetheless, new breakthroughs in computer technology will continue and major new opportunities will emerge periodically. Many of the advances in sociological computing during the next few years undoubtedly will follow the lines of progress already described: the hypertext networks, integrated high-performance graphic data analysis stations, software for computers, supported cooperative work, and neural networks for complex models of social systems. Perhaps the most exciting challenge for the future involves a concert of these innovations directed at the problem of modeling and analyzing vast amounts of social data. One solution would be to incorporate three-dimensional, multicolored, dynamic graphical representation of complex social data structures. But new techniques for analyzing these data will require new models of dynamic social structures as well as parallel social processes. Computer representations of these models tend to require extremely fast processing. Access to such models on the web, supplemented with audio and video displays, may evolve into an important part of the sociologist's toolkit of the future. Now we will discuss about geographical information system, the remote sensing, and its relevance to the population studies. The notion of using remotely sensed data to identify housing structures for population work has existed for well over a half century in the literature. For example, United States Census Bureau explored the feasibility of using aerial photography in an effort to locate human habitats in remote areas in order to reduce the decennial census reference. Remotely sensed data offers the means to measure spatial attributes of the urban landscapes. In the past, researchers remained dependent on aerial photographs because of their fine spatial resolution to get accurate data about size of houses and their volumes, and consequently estimates of population. Aerial data and photography is not allowed to be exported from some countries, but satellite images are occasionally available and can be collected from everywhere. 1 meter resolution satellite sensor usually covers a wider field of view to compare to aerial photographs, meaning that satellite data are usually less expensive than aerial photographs per 2 kilometers. In addition to that, remotely sensed data provide a wider spectral coverage, like number of bands. Due to these advances, there is a general trend toward using remotely sensed data for census studies. While these efforts have shown promise, they have all lacked the use of high spatial resolution imagery. This work extends previous studies that have tested the accuracy of the resulted population estimates using remote sensing. Progressively, switching over remotely sensed data obtained from government-sponsored satellite programs such as Landsat, SPOT, Radast, IRS to commercial satellites such as IKONOS, QuickBird and ORB View after 1999 has improved the state of art. These satellites promise to provide unprecedented access to accurate and timely information. Now we will discuss in detail about the Geographic Information System for population studies. The use of GIS, Geographic Information System, for population studies ranges from creation of maps to modeling the relationship between population variables. Here, GIS is used for both options, that is, for creation of maps and modeling. The creation of maps is a straightforward process in GIS. Modeling in GIS environment has taken different approaches ranging from loose to very strong coupling. Loose coupling involves importing or exporting data from separate configured software. For instance, linking ARC or info with epidemiological models. Previous studies have shown the importance of integrating remote sensing with GIS for population studies. The integration of all these information normally takes the form of using remote sensing data as a source of data or using GIS as in situ tool. Remote sensing and GIS results of analysis have been integrated for further spatial analysis. Students, now we will discuss various limitations of using remote sensing for population studies. Despite the positive developments in remotely sensed data, such as high spatial, spectral and temporal resolutions, there are still some limitations with respect to the use of these data for monitoring urban areas in general and population studies in particular. The limitations include spatial resolutions. The single most important technical issue in urban remote sensing in the spatial resolution of the image data. The last 30 years have seen development in the spatial resolution of satellite images from 30 meters Landsat MSS to 10 m spot HRV and 1 m IKONOS. The improvement in spatial resolution allows greater discrimination of the urban fabric. However, the use of very high spatial resolution images bring with them some major problems such as availability in panchromatic mode and large size of storage and processing time. Although some solutions like image fusion and image compression had been made to minimize and solve these problems, these solutions are not commonly available for practitioners in the census field. Now we will discuss about image classification. The heterogeneous nature, which means mixed pixels of urban environment, and the possibility that identical spectral reflectance values can correspond to very different land uses and functions possess a classification problem, efforts have been made to solve these problems. For example, by coupling automatic and semi-automatic classification, improving the results achieved using traditional per pixel classification algorithms by using a priori probabilities or a posteriori processing using of new algorithms such as soft classifier, Bayesian probabilities, fuzzy sets, combining spectral data with measures of urban form and texture and using of knowledge-based methods and artificial neural networks. However, these techniques are experimental and not yet included in standard image processing softwares. 3D nature of urban areas, imaging 3D buildings from satellites suffer from three problems. The first one is related to displacement of buildings from their true location, which is also called as relief displacement. The second one is related to obscuring of lower buildings by higher ones, and the third is related to shadow. Although efforts have been made to minimize these problems, up-to-date images such as those from IKONOS suffer from these problems. Due to the above limitations, remote sensing has to be used in conjunction with other sources of information such as maps, census data, field surveys, and GIS to provide better results. In addition to that, visual interpretation has to be used to strengthen the digital image classification. So what are the future concerns of using information technology in population studies research? Increasing representation of a wide variety of content in digital form results in easier and cheaper duplication of distribution of information. This has a mixed effect on the provision of content. On the other hand, content can be distributed at a lower unit cost. distribution of content outside of channels that respect intellectual property rights can reduce the incentives of creators and distributors to produce and make content available in the first place. Information technology raises a host of questions about intellectual property, protection, and new tools and regulations have to be developed in order to solve this problem. Many issues also surround free speech and regulation of content on the internet, and there continue to be calls for mechanisms to control objectionable content. However, it is very difficult to find a sensible solution. Dealing with indecent material involves understanding not only the views on such topics but also their evolution over time. Furthermore, the same technology that allows for content filtering with respect to decency can be used to filter political speech and to restrict access to political material. Thus, if censorship does not appear to be an opinion or an option, a possible solution might be labeling. The idea is that consumers will be better informed in their decisions to avoid objectionable content. The rapid increase in computing and communication power has raised considerable concern about privacy both in the public and private sector. Decreases in the cost of data storage and information processing make it likely that it will become practicable for both government and private data mining enterprises to collect detailed dossiers on all citizens. As we know that it's difficult to find out who currently collects data about individuals, how this data is used and shared, and how this data might be misused. These concerns lower the consumer's trust in online institutions and communications and thus inhibit the development of electronic commerce. A technological approach to protecting privacy might be cryptography, although it might be claimed that cryptography presents a serious barrier to criminal investigation. It is popular wisdom that people today suffer information overload. A lot of information available on the internet is incomplete and even incorrect. People spend more and more of their time absorbing irrelevant information just because it is available and they think they should know about it. Therefore, it must be studied how people assign credibility to the information they collect in order to invent and develop new credibility system to help consumers to manage the information overload. Technological progress inevitably creates dependence on technology. Indeed, the creation of vital infrastructure ensures dependence on that infrastructure. As surely as the world is now dependent on its transport, telephone, and other infrastructures, it will be dependent on the emerging information infrastructure. Dependence on technology can bring risks. Failure in the technological infrastructure can cause the collapse of economic and social functionality. Blackouts of long-distance telephone service, credit data system, electronic fund transfer systems, and other such vital communication and information processing services would undoubtedly cause widespread economic disruption. However, it is probably impossible to avoid technological dependence. Therefore, what must be considered is the exposure brought from dependence on how technologies with recognizable probability of failure, no workable substitute at hand, and high cost as a result of failure. The ongoing computing and communications revolution has numerous economic and social impacts on modern society and requires serious social science investigation in order to manage its risks and dangers. Therefore, in conclusion, we can say that such works of information technology would be valuable for both social policy and technology design. Decisions have to be taken carefully hence. Many choices being made now will be costly and difficult to modify in future. Therefore, the right use of information technology in research methodology, especially related to population studies, has to be made a wise decision according to the various social, economic, cultural, political, and demographic issues. Thank you.